Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, we are going to continue our advanced Agentic RAG series. In this specific video, we will go ahead and understand what exactly is Agentic RAG is all about, how it is different from traditional RAG. Along with that, we'll also go ahead and do the implementation with Python and LangGraph and LangChain. So we'll be going ahead and implementing all these things as we go ahead. Please make sure that whatever videos that I'm trying to upload right now, it is super important in every companies when you really want to develop some amazing RAG with specific autonomous agents. This all series of videos will be important based on different use cases. You may have to require different types of RAG. So my suggestion would be that please go ahead and implement along with me, right? So let's go ahead. But before I go ahead, I really want to quickly announce an important announcement. Since right now we have an amazing festive season of Diwali, all the live courses in Krish Naik Academy is available with 20% off. You just need to go ahead and use code AI20. So if you see, we have a lot of live classes which is currently going on, from AI for leaders and professionals, LLM ops, ultimate data science and Gen AI, ultimate RAG bootcamp. Then we have building agentic AI and Gen AI course 2.0. This ultimate RAG bootcamp is also starting, like it is a new course and it is going to start on November 2nd. So if anybody is basically interested to probably go ahead and join, where our team will be taking care of all the live sessions and giving you an amazing experience, you can go ahead and check it out. All the information will be given in the description of this particular video. Now, quickly, let us go ahead and understand about agentic RAG and how it is completely different from a traditional RAG. Already in our series of videos, we have already learned about traditional RAG. I've also uploaded an amazing crash course on traditional RAG, and I've shown you all everything that you really need to understand it over there, right? Now, let's go ahead and understand. With respect to agentic RAG, there are two main important components, okay? The first component is RAG, which is nothing but Retrieval-Augmented Generation. And the second component is nothing but autonomous agent, right? Now, these two components is the most core important thing of an agentic RAG. So if you really want to go ahead and define agentic RAG, it is an advanced AI system architecture where an autonomous agent, now this is really important, where an autonomous agent makes intelligent, dynamic decisions about the retrieval and generation. Now this is really important to understand. This definition is the core behind agentic RAG and its types, right? So here I've written the main work that you will be able to see is of this autonomous agent. So one core component will be autonomous agent, which we regularly create in agentic RAG in the form of a workflow. And the other component is simply RAG, right? Whenever we talk about RAG, this can be anything. It can be an external API, it can be an external tool, it can be a tool, it can be a vector DB, right? It can be any kind of databases, right? It can be anything as such. So this is nothing but it is an external data source. So here, whenever we talk about RAG, we are basically talking about external data source, right? And here the autonomous agent will basically take all the decision, right, about the retrieval. So from where we should probably go ahead and take the context, right? And how should we give the context to the LLMs, right? So in short, if I probably consider with a traditional RAG, in a traditional RAG, what do you have? Let's say that there's a human over here. The human will basically give the query, right? So let's say this is my query over here. Now this query will, what it will happen, it will just go ahead and let's say that there is some kind of vector databases or any kind of tool. Let's say this is my vector DB. It will go ahead and probably give this particular query, and based on this query and based on the embedding techniques that we have applied, in return we will be getting some kind of context, and this context along with the prompt is basically given to the LLM, right? And LLM will finally generate the output. So this is what a traditional RAG looks like, right? Now, how you are basically considering, or what difference do you find from a traditional RAG and an agentic RAG? It is very simple, right? So here, traditional RAG system it only allows a fixed retrieve and then generate pipeline. So it is following this specific fixed pipeline, right? It has to go in this way. There is a query. It'll go ahead and probably get the context from the vector DB. It is going to probably combine it with a prompt and give it to the LLM and finally generate the output, right? So this is how the pipeline will be going ahead. But in case of agentic RAG, we are using autonomous agents, and this autonomous agent is responsible for intelligent and dynamic decision and things, right? It probably based on its reasoning capabilities, right? It will probably make a decision like which tools to call, how to get the retrieval and all, right? So here there are 5 more important points which I really want to talk about, right? What does autonomous agent do? It basically knows when to retrieve info. Okay, I'll just go ahead and write when to retrieve info, what to retrieve, what to retrieve. Third important thing is that where to retrieve. And fourth is how many times to retrieve. Okay. So these are some of the important points, right? And this all decision is basically taken by what? Autonomous agents, right? So that is why we say that agentic RAG is very important. And the future right now is all about developing this kind of autonomous agents, right? For different purpose. So these are the main 2 important things. Now, I hope you got an idea about agentic RAG, how it is different from a traditional RAG. Now, the next step is that we are going to go ahead and implement this workflow, wherein this basically defines an agentic RAG workflow. Okay, agentic RAG workflow. Now, you may be thinking, why you're saying this as an agentic RAG? Now, see this workflow. Okay, and this we are going to implement it with the help of LangGraph. Okay, because LangGraph actually helps you to create an amazing workflow itself. So here, whenever a user gives a query, we will probably go ahead and go to the first node. This node will be acting like an agent. Okay, this will be my agent 1. And this agent will be deciding whether we need to go ahead and request the context from the retriever or directly we should generate it. Here, the generation is definitely taken from an LLM. Here, the retriever will be an external vector DB. It can be a vector store. In our case, we will try to create a vector store. So it will probably make this particular decision, whether we need to go over here, whether it needs to go over here. Okay. And this is what an autonomous agent is basically doing over here, right? And based on this, it will go ahead and assign that specific task and finally we'll be able to generate it. Amazing example altogether. So quickly, let's go ahead and implement this. So I will basically continue the same projects that we have actually done for the traditional RAG. We had all the notebooks. We have also implemented about modular coding. So you can just go ahead and explore all those things. This is what my agentic RAG basically looks like. Here I've created some sections. We will go ahead and start working on this. Now, the first thing that you actually require is that since we are going to use LangGraph, so for LangGraph, what we really need to do is that we need to go ahead and install some of the libraries, right? Like LangGraph and all. So here what I'll do, so in my requirement.txt, I've added a couple of libraries called as LangChain, OpenAI, and LangGraph. LangChain, OpenAI, the reason is very simple. I want to use OpenAI API keys over here because whenever you try to create an agent, the decision that the agent actually takes, it is directly proportional to the better LLM models that we use. And right now, OpenAI has a very good LLM models if we specifically want to create this kind of applications to be true, right? So all those things we will be discussing over here. That's the best part, you know. So here, once you go ahead and update this requirement.txt, all you have to do is that just go ahead and write uv add -r requirement.txt. You can see that I've already installed all the packages. Okay. Now, if I go to the agentic rag.ipynb file, so first of all, this is just a title over here. Now, the first thing that I'm actually going to do, I'll create a code cell. Here also, I'll create some of the code cell. The first thing that I require is some of the installation of important libraries. So here I'm going to use, I've already created a dedicated playlist on LangGraph. I think you should be having some prerequisite knowledge of LangGraph so that we take up this series in a serious way. So first of all, you can see that I've imported type date list. Then I have state graph. Then I'm using chat OpenAI embeddings. I'm using this vector store called as fires. Then I have recursive character text splitter. Then finally I have a document, right? So recursive character text splitter is specifically used for splitting text. So if I don't know whether I want to use this or not, but definitely let's see in the later stages. Whenever I see this, I will try to use it. Right. Then here you have text splitter. Then you have langchain underscore community dot vector stores, chat OpenAI, OpenAI embeddings we are going to use. Right. So once this is done, then the next step will be that we will be loading our environment variables. And as I said, I'm going to go ahead and use my OpenAI API key. My OpenAI API key is updated in the .env file. You should also go ahead and update it. Right. So here we can quickly go ahead and do this, right, wherein we are importing all the libraries. Then finally, I will also go ahead and load my environment variables, OpenAI API key. So I'll write os.environment, and here instead of writing os.environment, I'll say env, get env, and here I'm going to go ahead and give my OpenAI API key. Okay, perfect. So here you can see that I'm using GPT 3.5 instead of using this. I can use 4.1. That is good. So here I have my LLM. So you can go ahead and check out what is my LLM. So here you can see that I'm used this particular LLM model, right? GPT 4.1. That is the model name that I'm actually going to use. Now the next thing is that we will go ahead and define our state definition. Remember, whenever we define any kind of workflows, we need to define this particular state definition, right? Now here, the important state definition can be, since we are giving a query, so question can be one variable that we need to use. Then you'll be able to see that here we are deciding something, right? So deciding whether to go to the retrieve or generate. So here we can create a Boolean variable so that we can say that, hey, if it is probably taking a retriever, make that true, otherwise make it as false, right? So that is the second variable that I really want to use. And if it goes to the retriever, it is going to take out some of the context information. So that I really want to keep in the form of documents. Okay. And finally, the whatever the output generation is basically happening, we'll also store that in some variable. So here inside my state definition, I will define a class called as agent state. It is inheriting type dictionary. And here you will be able to see that I'll be using question is equal to str. Okay. And here you'll be able to see I'm using documents, list of documents, then answer is equal to str and needs retriever as Boolean variable. So I have defined all the specific variables over here. Okay. Now, once this is done, let's also create a sample documents. Now I have to go ahead and create some kind of sample documents and vector store, right? I'll also go ahead and create this. Okay. See, creating a documents is very simple. You can either read it from the PDF file and all. But what I am actually going to do is that I'll just take some sample text that is generated. So here you can see that I've taken 4 different text: LangGraph, RAG, vector database, agentic AI system. So I've taken some 4 different sentence, and then I will convert this into a documents. So document is really important. All right. Now with respect to the document, I will go ahead and use my document over here. Okay. And with respect to document, I will say, hey, let's go ahead and use this page content, and then this will be text. Okay. And here I can go ahead and iterate it for text in sample underscore text, right? And then finally, let's go ahead and create a vector store, right? So for creating a vector store, it is very simple. We will go ahead and use this. Okay, fires from this documents, and here you can see I will just go ahead and name this as documents. And here as retriever, I'll make it as 3. See, this is what is my vector store. By using fires, which we have already discussed, retriever, we're converting this into a retriever, and done. That's a good one, right? Now I will delete all these cells because it is not required. Okay. Now I have my retriever, I have my state definition. Now it's time that we start defining agentic functions. Now what exactly is agentic function? Now see, over here, what is the main functionality of the agents, right? This node may have a different definition. This node may have a different definition. This node may have a different definition, right? So we need to go ahead and define all those definitions. So first of all, the first is deciding, right, whether we need to go to the retrieval or generate, right? So for that, I will create a function. Now here, I'm not going to use any kind of LLM. We'll use simple plain Python code. So here you can see I have defined a function called as decide retrieval. The state is given as agent state, and over here. And we are deciding if we need to retrieve the documents based on the question. So first of all, we need to get the question. So obviously we will put the question in the state variable, which is coming from the agent state initially, right? And then I will get this particular question. And now here I can replace this code with my LLM also. I can give a prompt. The LLM should decide whether we need to go to the retrieval or directly we should generate by the LLM. But here what I'm doing is that I'll show you with very basic conditions how I'm writing this particular function. So here I've used retrieval keywords, and whenever my question contains this words, right? Like what, how, explain, describe, tell me, at that point of time, I'll make this Boolean variable as true, needs underscore retrieval. That basically means if this exists in my question, then definitely we need to go ahead with the retriever, right? So this needs retrieval will be basically set to true, right? So that is what we are basically checking over here. And we are returning state with this needs retrieval, whatever needs retrieval value is, which is a Boolean one, right? So this is my first function. So here I will just go ahead and execute it. The second function, it is retrieve documents, right? Now you know how to retrieve the documents. It is basically from FIS or retriever, right? So here I have defined a retrieve documents. State is equal to agent state over here. Then question is equal to state of question. Documents is equal to retriever.invoke of question. So we are now invoking from this to get the context. So once we have whatever we get the context, so it will be stored over here. And we are returning this particular value wherein we are updating this documents variable, which is present inside my agent state, right? So here you will be able to see that I will be saving this particular value also. Okay. Then let's finally go ahead and generate the answer. That will be my third node definition. Now generating part is very simple. Here I'll take the question, I'll take the documents. If there is a document, see, when we are taking the documents, right? If nothing is present over here, we'll keep it as empty. So if documents are there, what I will do, I will create a prompt. I'll say based on the following context, answer the following question, answer this each and every information over here. So here you will be able to see that I'm getting the questions, I'm able to probably answer this. And finally, you can see that I'm invoking it with the help of prompt and response.content. If there is nothing in the documents, directly it will go ahead and set up this particular prompt and it will generate the answer. And finally, I will also be able to get the answer. There are two important conditions, guys. Very clear, very simple, very easy. If there is a document present, we will set up the context, we will set up the prompt. And finally, we will, in the else condition, if it does not present, we'll set up a prompt and we'll say LLM to invoke it and we'll get the content. And that content is nothing but your answer. So three important function I've actually defined it. Okay. Now comes like how should we generate the conditional logic? Now see, why is conditional logic required? See, after this particular node, there are two arrows, either this or this, right? I know decide function is what? It is basically setting up that needs retrieval is equal to true or false, but it also needs to make sure to traverse over here. Either it should go to the retrieve or generate. So now what we'll do, we'll put this as conditional logic. Whenever we say conditional logic, when does that basically happen? Whenever there is a two path from a simple node. Okay. So here there is a two path. So I will go ahead and define my conditional. And this function I will define it as should retrieve. Now here I'm just saying if state of needs retrieval, then go to retrieve node, otherwise go to generate node. Okay. Very simple. And I'll go ahead and execute this. Now finally, we will go ahead and build the graph. Now building the graph is very simple. Okay. And first of all, I need to go ahead and write how many nodes we have. So I have decide node, retrieve node, and generate node. Okay. So for decide, you will be able to see that I have something called as retrieve documents over here. Then I have generate answer. This all function has been defined. Now how the nodes are basically connected. So for this, first of all, I will go ahead and set an entry point. Okay. Now entry point basically means from start to decide. See over here, the first path is start to decide. Then from decide, you have either retrieve or generate. Okay. So here, whenever we say retrieve or generate, here we'll add a conditional logic. Okay. Now for adding a conditional logic, it is very simple. We will set up the next thing, conditional logic. Here I'm writing workflow.add conditional edges, decide. Okay, from decide node, we will call this function should retrieve. Now what is should retrieve doing? It will check whether the needs retrieval is there. It will return retrieve, otherwise it will generate. Okay. So here we are returning retrieve or generate. For this retrieve, which node to probably connect it? So from retrieve, we have to connect to this particular node, which will indirectly call this particular function. And from generate, we are going to call this particular node, and the mapping will be for generate answer, right? So that is what is my conditional edges. Now, after the conditional edges, one more very important thing is that from retrieve, I need to go to generate and then end. From decide, it is going to generate only, and then from generate to end. Okay. So that path also we need to go ahead and add it up. So here I'm going to go ahead and add the edges. Here you can see retrieve to generate, generate to end. And finally, I'm compiling the graph. Okay. And now let's see the graph, whether it is coming or not. See, start, decide, conditional logic is there, retrieve, generate. And finally, you will be able to see that it is in the end. Now, finally, we should be able to go ahead and run this particular workflow and test it out. Okay. So let's test the agentic system. Now, I hope you have understood it, what exactly we are doing. So for testing it, here I'm going to go ahead and define a definition, ask question, right? So here we'll give the question. This question will be set up in the initial state on this particular variable. Question is equal to question and documents answer need retrieval is false. Then we are going to invoke by this particular app, which is my workflow, right? And it's just going to go through this and generate me an output, right? Return result. So now let's quickly go ahead and do this. And now let's test a question. What is LangGraph? I know it is basically available in the retriever, and I'll just go ahead and print this. So result one should be giving me question, answer, documents, all the things. So question is over here, what is LangGraph? Now documents is over here. You can see that I'm getting all this from the retriever. And this is my answer. LangGraph is a library. And needs retriever is true. That basically means obviously it is hitting the retriever, right? Now, for this, if I really want to display it in a much more better way, I will try to show you to one more question. So let's test with another one. How does RAG work? Am I using this answer question? And then we are seeing question. How many retrieved documents are there? What is the result? Each and every information. And here you can clearly see, I'll just take some time for displaying things. Okay, let's wait and should be able to display the answer. I think my OpenAI API key is, okay, it works. So how does RAG work? So here you can see that I'm getting all the 4 documents and finally I'm able to generate the output, right? See, all these answers, retrieved documents are 4, all the values are there. So I hope we are really good to get started with Agentic RAG, right? Now you just go ahead and create your own workflow where you have some kind of deciding agent, which will be acting as an autonomous agent out there and making the specific decisions, right? So we will keep a light target of 1,000 guys. It takes a lot of effort to make all these particular videos. I definitely want your support. Yeah, this was it from my side. I'll see you in the next video. Thank you. Take care. Have a great day. Bye-bye.